we go. I also need to grab, I'm going to really quick grab a unit circle. Because I need a unit circle. Oh, do I need a unit circle on this? Actually, I don't think I do need a unit circle. I think they're all, okay. All right. So here we go. We're going to work on examples. What did we say? We're going to start with example 5, or actually we're going to start with this box that says co-function identities and even and odd identities. Okay. Oh, I know I had a unit circle there. Let me look at and grab the unit circle from here just so I can talk about this. Okay. So there are patterns in the unit circle, right? We've noticed these patterns. So there's some things that are the same, okay? And this is where these co-function identities come in, okay? Pi over 2 is like 90 degrees, right? So if I take and I notice that two things that add up to 90, because this is saying 90 minus an angle measure, okay? So let's say I'm looking at this part of the unit circle here in quadrant 1, okay? And in quadrant 1, let's say I'm going to look at pi over 6, this angle here, okay, and pi over 3, okay, which would really just be, and this angle here, okay. And technically, if I add those two together, I would get 3 pi over 2, because isn't this, look at this, if I was looking at this right in here, okay, I know that this part is pi over 3, and I know that this is another pi over 6. So if I add those two angles up, I know I get pi over 2, okay? But look at this. Look at the cosine of this one and the sine of that one. What do you notice about those values? They're the same, okay? Same thing here. The sine of this one and the cosine of that one are what? The same. Nope, remember, you know how these two are exactly the same? Pi over 4 plus another pi over 4 is the 90. It's the pi over 2. And notice the values are the same. Okay? That's what the co-function identities are. Okay? Is they tell us where the values are the same. Okay? So really all an identity is, it's a formula or it's something that I'm allowed to substitute in for something else. Okay? So, when I have the sine of pi over 2 minus u, or some variable, it could be an x, it could be a theta, okay? I know that that is equal to the cosine of u. So the sine of pi over 2 minus u is the same as cosine of u. The cosine of pi over 2 minus u is the same as the sine of u. So if I see this one, I can substitute a cosine in. If I see this one, I can substitute a sine in, okay? For tangent, it goes with cotangent this time. So the tangent of pi over 2 minus u is the cotangent of u. And the cotangent of pi over 2 minus u is the tangent of u. And then finally, what's left? What has to go with secant? Cosecant. So the secant of pi over 2 minus u is the cosecant of u, and the cosecant of pi over 2 minus u is the secant of u. Now, I am not going to do all 6 of those in the notes. We're going to do 2 examples, okay? And then there's another 3 in the homework. And so the 2 examples in the notes might not be exactly these, but they're going to act exactly the same way, okay? All right, so let's do some co-function identities before we talk about the even and odd identities. Okay, so let's do a couple problems with that. Okay, so our instructions are exactly the same as yesterday. Okay, use the given values to evaluate, if possible, all 6 trig functions. Okay, now I am well aware that we could get out a triangle and a Pythagorean theorem and do this. Okay, totally could do that. And I purposely picked numbers that were easy so we weren't bogged down in the numbers and having to deal with radicals, okay? The idea here is we're learning a new trigonometric concept that is the same as, it's another way to do what we did with the Pythagorean theorem and the triangles and the SOHCAHTOA triangles, okay? It's just another way to do it. With trigonometry, there's like 47 different ways to do every single thing, okay? And that way you pick the one that works best for you when you need it, okay? All right, so all I am doing is I am coming up here, and I am noticing I have the sine of pi over 2 minus x. What do I get to replace that with? Cosine. So I'm substituting cosine in here. So cosine of x is 8 over 17. So that's really saying not sine of x, but cosine of x is 8 over 17. Okay. They also gave me sine of x. So I have to find the other 6 now. I've got 2 of them. The best thing to do next would be to do reciprocals, right? So what's the reciprocal of cosine? Secant. So secant of x equals, what's secant going to be? 17 over 8. What's the reciprocal of sine? Cosecant. Okay, what's cosecant going to be? Good, 17 over 15. All right, what am I missing? Tangent and cotangent. Okay, so what I need to do is I need to find a formula or an identity that relates one of these things to tangent or cotangent. Okay. I would probably do sine over cosine. Okay, because I know that one. All right. So I'm going to do the tangent of x equals the sine. I'm going to write it out over cosine. So that's going to be 15 over 17 divided by 8 over 17. Oh, our shortcuts there, right? Can't I just cancel the 17s? So we're equal to, so tangent is 15 over 8. Thank you, kiddo. All right. So what is the cotangent then? 8 over 15. Okay. Here's the thing. I didn't have to use that one. Could I have gotten out? I could have gotten out my Pythagorean identity. So this is just watch. This is another way to do it. You don't need to write this down. I could have see the Pythagorean identity up there that says 1 plus tangent squared equals secant squared. So 1 plus tangent squared equals secant squared. Okay. I could have done that one. 1 plus, I don't know what tangent squared is, equals my secant, which is 17 over 8 squared. All right. Let's see. 17 squared is, I believe it's 289. Am I right about that? Over 64. Help me out. I don't have my posters up, do I? Where do my posters even folded weird? Let's see. 17 times 17. 289. Okay. So I would make this 64 over 64. Okay. I would subtract that to the other side. You've seen why I picked the fraction one. 289 minus 64 is 225. And then how do I undo the square? Square root. So I get 15 over 8. Did I end up with the same answer that I had before? Yeah. So do you see how there is more than one way to take care of this? Okay. You can kind of pick what works for you. I would do quotients and reciprocals as much as I can, and then use Pythagorean as the backup. Okay. All right. I have no idea why there's a P after example 6. Okay. So erase or cross out the P. I don't know why that ended up there. Let's fix that. Okay. Here's what I want you to do. Okay. I have very few examples on this, right? So you're going to try one on your own now. Okay. So let's refresh and remember what we did. We took this. Ooh, where'd it go? All right. We took this. Maybe. There we go. We took that and we went up to our chart and we found the one that we can substitute in for it. Okay. From there, we found our other 6 through reciprocals and quotients. Okay. So everybody right now, I'm going to give you 2 minutes. Everybody is going to try example 6 on your own. And Lisa, did you have a pass? Okay, that would be great. That works as a pass. Okay. Brooklyn, did you have a pass? Do you have the same little thing? So I just don't want to mark you tardy if you weren't tardy. Thank you. right there. Make sure you're trying it. This is your opportunity to see if you know how to do it and can answer and get asked questions. Okay, we're going to check it over, okay? So, our goal, again, was to use the cofunction identity first, okay? So, what did I get to substitute in for tangent of pi over 2 minus x? What did our chart say? Cotangent goes in there. So, again, I'm using the chart to help me. I'm using that, okay? You will have the chart, okay? So, you don't need to memorize it. So, cotangent of x is really equal to 5 over 12, okay? What should I find next? No, because this is equivalent to cotangent. They're the same thing. So this is another name for cotangent. Does that make sense, Dion? Okay. All right. So if we know that that's another name for cotangent, what's easy to find from here? What should be the next one I look for? Tangent. Okay, so what's tangent going to be? Good. I'm just going to flip the reciprocal. Okay. What else do I get for free? Secant, because I've got the cosine, right? So secant equals 13 over 12. Perfect. Okay. Now, I'm missing sine, and I am missing cosecant. So there's two different ways I could find it. So either we're going to do quotient, okay, or we're going to do Pythagorean. So which one do you guys want to do, quotient or Pythagorean? Pythagorean. Okay, so I heard Pythagorean. It's going to be that first one up there on the pink sign, right? Sine squared plus cosine squared equals 1. Okay. So, and sometimes I'll write it out just like this. Sine squared plus cosine squared equals 1. Okay. So the sine, I don't know. So I'm going to leave it as sine squared x. The cosine, I'm going to put in as 12 over 13 squared. Okay. And then I don't really know what I want here yet for the 1. I'm just going to leave it 1. Okay. So sine squared x equals, what's 12 squared? I don't know why I wrote an equal sign. 144. Good. What is 13 squared? 169. So if I'm going to work smart, I want to turn that 1 into 169 over 169. Okay, so sine squared x equals. I have to take 169, I have to subtract 144. So it's 169 minus 144. You guys can do this. 25. Good. 25 over 169. Okay. How do I undo the square? Square root. Now, technically, when I take a square root, it's a plus minus, right? So I need to figure out if I want the positive or the negative. We'll do that in a second. Okay. What is the square root of 25? 5. Okay. All right. 5. And what's the square root of 169? 13. It should check out. Look at what we have here. It should be the same numbers as what we have there. Okay. In some way, shape, or form. Okay. Now, let's talk positives and negatives really quick. Go back to this acronym. All students take calculus, right? Cotangent is positive because that's what we started with, right? Which quadrants is cotangent allowed to be positive in? First and third. Okay, and then I also had cosine positive out of those two. Which one's cosine positive in? The first. Do you see why that was really important that we knew that we got that from like a month and a half ago? So that means that this is going to be the positive version, not the negative version, because I'm in quadrant 1. Okay. All right, we got sine. What can I get from sine? And what's cosecant going to be? 13 over 5. Yes, because this is another name for cotangent. Okay, that's what the identity up here told us. Okay, right? That this I pluck out and I put in cotangent. Okay, if I had cotangent, I'd pluck this out and I'd put tangent in. It's like substitution method. Okay, we're just substituting in. Okay, we're renaming it. Okay, all right. Any questions on those two? Because we're going to move to something else. Okay, those are the only two we're going to do cofunction. I have a couple more. I have 3 more for you to try in the homework. Okay, all right. Let's talk about even and odd. Okay, so when we have functions, we have sometimes there's functions that are even, and those are the ones, remember, that point the same direction, and you can have like all kinds of loop-de-loops, and as long as they're pointing the same direction, those are even functions. Okay, we also have odd functions where they can point opposite directions. We can do all kinds of loop-de-loops or whatever we wanted, and those would be odd functions. Okay, but we can't always tell by the picture. Okay, so there's a property that says a function is even if when you substitute a negative x in, you get the original function back. Okay, if you substitute a negative x in and you get the negative of the function, it's odd. Okay, so that's where the background on where these funky things come from up here. Okay, so cosine and secant are even functions. So there, when you put the negative x in, you're going to get cosine u or secant u. You get the original function back because those two are even. Okay. All right. For the others, they're all odd. Okay, so what that means is when I have a negative u that gets substituted in, it makes the function negative. So it'd be negative sine u, negative cosecant u, negative tangent of u, and negative cotangent of u. Again, you're going to have those. Okay, so you don't have to have it memorized. All right. And it's just a substitution. When you see negative cosine of negative u, you're going to replace it with cosine of u. Their two things are equivalent to one another. Okay. When you see cotangent of negative u, you're going to replace it with negative cotangent u. You're plucking one out, putting the other one in. Okay. All right. So let's try that. Okay. All right. So again, I've still got to get the 6 trig functions, right? They gave me cosine of negative x and cotangent of negative 16 over 60. Okay. So I see cosine of negative x. Okay. I am going to replace that with, what am I allowed to replace it with? What's it say? What's wrong? You didn't get that page? I just passed them out. Did your table not get one? There we go. I gave them to your table, didn't I? Did somebody at your table not pass them out? There we go. We'll give table 2 a minute. Did everyone else get them passed out? I kind of snuck them on your table, right? While you were doing the last example. Okay, are we good? Okay, so let's go back and refresh what we were doing there. Okay, so we have cosine of negative x. I have to find something to replace that part of the equation. I'm going to go up to my chart. What am I allowed to put in for it? Cosine of x, right? The u is just a placeholder for the variable, right? So this is getting replaced with cosine x equals 16 over 65. Okay, before I get excited about my reciprocals, let's figure out what quadrant we're in, because I might need that later. Okay, so cosine is positive. Where's cosine positive? Which quadrants? First and fourth. Good. Okay, and I'm hearing a lot more people answer that, so that's awesome. Okay, all right. And then it says cotangent is negative. So is cotangent negative in the first or the fourth? Fourth. So I know all my answers have to be quadrant 4 answers. Okay, that helps me with my signs. All right. So going back to where we are at in the problem, for cosine, what do I get for free? Secant. So I get my reciprocal for free. So 65 over 16. Cotangent, what do I get for free? Tangent. So I'm going to flip this over for tangent, negative 60 over 16. Okay. I have choices from here, right? I could do a Pythagorean, okay, which I did in the last one, right? Or I could do a quotient, all right? Let me show you the quotient approach with this, okay? You don't have to do it this way. We could do the Pythagorean with your cosine and your sine, okay? But if I thought about tangent, okay, so tangent we know is the sine divided by the cosine, right? Okay, so for my tangent, I have negative 60 over 16. I'm just replacing it. I don't know sine. I'm trying to solve for that. Cosine, I know, is 16 divided by 65. Okay. Right now, this fraction is under division. How do I get it to the other side? I multiply. So I would take, I'm going to do it in a different color. Okay. So I'm going to take 16 over 65 and I'm going to multiply it by negative 60 over 16. What happens? What happens? Why was that really good? What do I get to do? You guys know this. I can cancel. What can I cancel? The 16s. Woohoo! So I've got negative 60 over 65 is the sine of x. Again, I could have used sine squared plus cosine squared equals 1 and I would have been fine. Okay? All right. And I don't even need to worry about the sine because it popped right out of it, right? What do I get for free now that I have sine? Cosecant. What's cosecant going to be? Perfect. Negative 65 over 60. Okay. So again, if you didn't like that one, go back and use Pythagorean like we did yesterday. Okay. Or earlier in the lesson today. Okay. Any questions on this one or anything you're confused about before I go to the next one? If you can, but you always leave it improper. Okay. We do not do mixed numbers in high school. I'm sorry. I don't know why they even teach them to you. Okay. Do number 8 while I'm getting the phone. Oh, or while I'm not getting the phone. Where's your phone? Okay, forward. Because the only place to plug it in is up there. So, because I didn't want my. Look at how small of a spot that is for my desk. Look at the size of my desk. I can't see. So, it's like right up there. It's like right behind you. So, all right. Everybody's trying this. Try example 8 for me. They'll call back. I know they will. Everybody do 8.
Can I use that?
Yeah. About 20 seconds and we're going to check it, okay? Okay, let's take a look. All right, so the key to the problem here is I have to replace this, okay? Let's go look. So what do I replace negative cosecant or cosecant of negative u with? What do I get to put in for it? What's it say? I'm sorry, my handwriting might be hindering that one. Where does the negative sign go? Does it disappear or does it go outside? It goes outside. That's the other way I think about it sometimes is on my even ones, the negative sign disappears. On the odd ones, the negative sign goes outside. Okay? So I'm going to literally take this out and I'm going to replace it with negative cosecant of x equals 13 over 12. I know this one went a little bit beyond where we did on the last one. So I can't have a negative in front there. How do I move that negative to the other side? Multiply or divide, it doesn't matter, right? So my cosecant is negative 13 over 12. Okay. I'm going to do this thing just in case, because maybe I'll use a Pythagorean. Oh, students, I'm messing up my acronym. Maybe I'll use a Pythagorean and I need it. Okay. So this is telling me the cosecant is negative. So what quadrants is the cosecant negative in? 2 and 3. No, not 2 and 3. 3 and 4. Good. Okay. And then it's telling me tangent has to be positive. So out of these two, which one is tangent positive? 3. So I know that I have to have a quadrant 3 answer. Okay. All right. So let's go back to cosecant. Who do I get for free from cosecant? Sine of x equals negative 12 over 13. Good. So I've got secant, cosecant, sine, and tangent. Who do I get from tangent? Cotangent of x equals what? 5 over 12. Okay. You tell me how you want me to show you. I don't care. I'll do whatever you want. Do you want me to use a Pythagorean or a quotient? Which one? Pythagorean. Okay, I'm happy with Pythagorean. We need to find cosine, right? So if I look up at my identities up there on the pink sign, I know that I want to use the one that has sine and cosine in it. So I'm going to use sine squared plus cosine squared equals 1. And I'm being super lazy and not writing variables there. All right, so I'm going to take this and I'm going to plug it in for sine. So negative 12 over 13 squared. Cosine squared x equals 1. Okay, what is negative 12 squared? 144. Do I want it positive or negative when I square? Positive. All right, what about 13 squared? Good. And again, we're going to work smart and not hard. I'm going to, instead of writing that as a 1, I'm going to write it as a 169 over 169 because that's my common denominator. Okay. I am going to subtract the 144 here. So it's 169 minus 144. Not 35.
No,
25 over 169. Okay. How do we undo the square? Square root, technically plus minus. All right, what's the square root of 25? 5. It's the square root of 169. 13, which makes sense, right? That's what we had over here. Okay. All right, now we got to decide on the sign. If I am in quadrant 3, does the sign positive or negative for cosine? Good. And then what do I get for free from cosine? Secant of x equals negative 13 over 5. Okay. All right. I'm going to give you like a 1-minute brain break because I didn't assign it yet. It might be 2 minutes. I'm going to assign it in Google Classroom here in just a second. Okay. It's going to be in Otis because that was just the best delivery method for this. Okay. So you can take a break.